Hello engineers, last time I set you the task of assigning a button to remove all the pictures in the LCD and assigning another button to add them all back. And you can do that using code that already exists in our block. We'll start with removing the pictures. We'll call that argument remove, all caps. You don't have to do all caps. Doesn't really matter as long as you keep it the same in the code block. Right here we need an if statement, not in caps, to check the argument. Remember, this comes in here, double equals, and then whatever you set it to, which was remove. Right, okay, if remove is clicked, then this will run whatever's in here, and we just need lcd.clear images from selection. Simple as that. And there it goes. They're all gone, and you can check nothing in the selected textures box. Now we need to add them all back, and the way we did this in code, let's tidy this up. Let's take out all the commented code because we obviously don't need that anymore. Okay, how did we add? We added images to selection. That was manually editing. Add images to selection, and then we just grab the list with all the image names on it. And the problem we're going to have here, you'll see in a second. We're going to assume I'll call the argument something like add, good enough for now. And then we will add that list of image names. And it will say image names does not exist in the current context. It can't find this because it exists inside of program. Image names. It can't be reached from anywhere outside of this code body here. In order for it to be reachable from outside, it would have to be created outside. So we would do something like I think we can just transplant the whole thing there. Successful. And that should be it, because once that's created, the code in here does the same thing as it did before. Adds images to selection. I mean, where does it actually add the images? That was it, wasn't it? It just splits the strings in custom data, doesn't it? And so yeah, this should all work. You just need to assign the button. I noticed that it already did it because I think that ran. So we'll just remove those, run that, there we go. Removed, added, removed, added, removed, and that unfortunately also adds the images back. That's just a side effect of the way we've written it. That'll do for now. We're going to move on to Pistons and Rotors. They're kind of simple, so I'm going to do them both in one video. Hopefully that will work out. Let's put a piston down and a new programmable block to use it, and let's give it a custom name of just piston. Now let's get that piston into code. I'm going to put this at the top so that it can be reached throughout the code. My piston base piston. Piston equals grid terminal system, capital S, dot get block with name, and then you give it the name, which was piston. Oops. As an my piston base. Does that all work? Grid terminal now. There we go. Okay, what are the properties of the piston? Okay. It's got a safety detach, which is to do with the head detaching from the body. We won't go into that. Reverse. Now, its velocity is what tells it which way to move, either extend or retract. If we step back a bit so we can see it, you'll see if you make it a positive number, it extends. If you make it a negative number, it retracts. And if you click reverse, it just switches the number from a negative to a positive or a positive to a negative. Maximum distance limits how high it can go. If we just set it to 1 meter, it doesn't get very far. And if we extend it out and then set a minimum distance, predictably, it doesn't quite get all the way back. And we could actually just move that. It reacts. Max impulse axis. Maximum force the piston is allowed to apply to a block obstacle along its extended axis. So that's to do with pushing objects that are in its way. And this is about objects that are in its way, but to the side. We're not going to get into these. Now in code, what we have that we can do, so we can set its velocity. Equals 1, and off it goes. Set its velocity to -1, off it goes. In main, we can say piston dot reverse, and then when we run it, it will click its reverse button. Let's set its limits. Max limit equals, put it to 1 meter again. Get it to reverse. It stops at 1 meter, and just copy this. And it ignored me. Love it when it does that. There we go. Min limit. Put the max limit back up to 10, because 10 is its max. Off it goes. And it stops at 1 meter. Cool, that's it, basically. That's the basics of a piston. Let's look at a rotor next. Now, a rotor has the degrees around it marked, and there's a little line here that shows you where it's currently pointing. At the moment, it's pointing at 0 degrees, which makes sense. Now let's slap one of these down. Now, rotor, let's make it lowercase r. Now we've got torque, which is the strength with which it turns. We can just leave that on max to make sure that it actually does move. its velocity is how fast you want it to turn. If you start it, you see it tells you the degree there, and as you can see, it's pushing its way around in the positive direction. And if we reverse that, nope, yes, I am working the piston, never mind. Rotor, here we are. Put it in negative RPM, and it will start winding back round towards 0. Now, if you set a lower limit of 0, it's tricky to do with the mouse, close enough, then it stops at -1 degree. Upper limit, let's set it to, there should be a way of just typing in a number here, but I can't remember how to do it. Let's put it at 90, give it a positive RPM. And it should stop at 90, and there we go. Rotor displacement, you can raise or lower the head slightly, so you can fine-tune whatever gizmo or gadget you're building. Let's see, there you go, so you lower it down and raise it up. Now in code, let's see, let's grab it first. This one has got a bit of a funny name. My motor stator equals motor. Okay. Morot. Something wrong with my brain. There we go. Right, let's set some things up. Motor. Rotor, even. Rotor dot target velocity is RPM. This is how we get it to move. Equals 2. Okay, and it won't move because we've set the limit to 90. So let's instead make it -2. And off it goes. We can actually set a more precise minimum value now. Lower limit. Now, you can either have this in degrees or radians. I'm going to be using degrees because then it matches what's written on the side of the rotor. Equals 0. Upper limit degree, and we'll make that 180. And then we will, still stuck on -1, so if we get it moving the other way, it'll, let's make it 5. really get it moving. Didn't get very far. Hang on. Upper limit degree. Not 18, 180. Off it goes. All the way around to 180. There we are. And that's as complex as we need to go into it right now. What we're going to do now is create some device combining these two, and I think it's going to be probably a bridge. Let me just oopsie. Nope, not that one. Not that one. Oh dear. There we go. Is it Alt? There we go. I'm going to just play with the sun. That's better. Right. Now we're going to need I think now we want this down here as 180 facing upwards. What we want to happen is we want this to extend a bridge outwards, and then the actual walkway will be underslung, and when it gets fully extended, the underslung walkway will rotate around so that we can walk onto it up here. Let's see if I've lined this all up properly. Sure how long that needs to be. That's probably too long. What I will do is delete the existing ones and then rename these. So we don't have to change the names in code. Build view or whatever it's called. Right. Now, what we'll do is we will. I was already there. Let's get the piston. Yeah. We don't want it to have any limits, and we want to extend fully. There we go. Oh, it looks like I gave it the right amount of panels. That's good. Now, if we just quickly grab this. That all worked out. And then we get rid of that. And then we say okay. It just wipes it. Cool. Save it. Right. Rotor dot target velocity revolutions per minute equals 2. Now the limit, oh, it's not, hang on. Okay. I forgot to put in some limits because I wanted to stop at 180. In degrees. 180. And lower limit. Right now it can only go between 0 and 180. Just one half circle arc. And we can go back to giving us speed 2. Right. There we are. And the bridge is in position. Now, the way we need this to work is... we need it to be able to extend out, and only when it's fully extended does the rotor then rotate the bridge up. And then when we retract the bridge, we need that rotor to rotate the bridge back down first, and then have the piston retract. So, to control this, I guess a good place to start is just having a button panel array. And we're probably going to want... hang on, let's name this. Bridge. There we go. Right, block bridge. And we'll give it extend. Right, and we'll probably want this one to be racked. And now we can write in the if statements. We're not going to want that, definitely not. If, okay, if argument is extend, then do something. And then likewise, we want the opposite. Don't know why I put it there. M equals retract, then do something. Now, what we're going to want to do is check. Let's just say we're going to retract the bridge. We need to check the rotation or the angle of the rotor periodically so that we know when it's reached 0. And then once it's reached 0, we can trigger the piston to retract. But in order to monitor the rotation angle, we need to constantly be checking it, which means this block has to be self-triggering. It has to be running through code over and over again. So we're going to need to be self-triggering. So it's going to use the runtime. Why is caps lock always on? Runtime dot date and c equals 10. I think that's the right code. Does not exist in the current context. Date 10. Are you sure? Oh yeah, it's an enum, so you need it to be... I thought it might be longer than that. There we go. Long-winded. Every 10 game ticks, it's going to run main. This doesn't matter because whatever's in here will only run if the argument comes through, and the argument is going to be coming through blank every time we update. So this will be bypassed, and we'll just be running whatever's below, which will be the check for the angle. Now I think what we need is a boolean at the top that keeps track of whether we're currently trying to extend the bridge or retract the bridge. So extending equals false. We'll start with extending equals false, and this boolean will be changed by these. If the argument extend comes through, then extending will be changed to true. And then if retract comes through, we reverse it. Right. So we'll need an if statement to check that boolean. And I think this is fairly quick. If extending, now I said we'd start with, whoa, don't lose my changes. I said we'd start with retracting, so let's start with retracting. We'll leave extending for now. If extending, you can just stick that in there and it evaluates to true or false, and when it's true, then it'll go through. If you want to check whether it's going to be false, use an exclamation mark at the beginning. This negates that, so whenever it's not extending, whether extending is false, this one will run. And at that point, that means we've pushed this button and we want the rotor to rotate the bridge down. So first of all, the moment retract is pushed, rotor, I think there's a reverse, isn't there? Rotor, there is a reverse. Dot. But we can't use it because otherwise it will just reverse every time we press retract, and we don't want it to reverse. We want it to be at a negative velocity. So target velocity, rotor dot target velocity equals 2. Is that right? Yeah, because we want it. No, wait a minute. -2, because it's at 180 at this point, and we want it to go anti-clockwise back to 0. We're at 180, and we want it to go around this way and then stop here. See what happens. Right, so it starts. It's a bit slow. Let's say we make it 5. Okay. Right. All the time it's doing that, and retract is what we're doing, then here we need to be checking if, you know what, we might as well stick the if in here, the second condition in here. Double ampersand is and then rotor dot equals 0. Now angle here is in radians and not degrees, but it doesn't matter because we're only checking 0, and 0 is the same in radians and degrees. So while we're not extending and we're actually retracting, the rotor angle equals 0, then we can set our piston off. Again, we can't use reverse because we need it definitely to go in one direction. -5. Let's keep this uniform. Pist does not exist. Oh yeah, pist on. So if we go rotor, oh, yep, it's already resetting itself. We'll have to check. We're actually going to have to get rid of that. It's doing that in here. Let's get rid of the velocities. The limits are good, but we can't get them moving in the program method. Right, retract. And as soon as that hits 0, that's good. Right, now we need to do the reverse. If extending is the case, then immediately piston dot velocity equals 5. We just get that to extend straight out. But what we're waiting for in if extending, just like here, we're going to be monitoring the position of the piston. Current position gives us the number of meters of extension it has. It's exactly this number here. Bridge. So if its current position is 10, then we can piston dot target velocity in RPM equals 5. It's not contained definition of target velocity RPM. Hang on, what did I just... Oh, piston dot. It's just velocity equals 5. Nope. No, I was right the first time. Oh, okay. No, I was right the first time. It's just that it's rotor dot target velocity equals 5. Done. Let's see if that's successful. Otherwise, we're going to end up mangling something. It stands out. Off we go. It should be limited to 180, so it will stop there. Now withdraw. And you can actually stop it and yep, you can just play around while it's doing its thing and it doesn't matter, it doesn't foul out. That's all right. That'll do. Right, why don't you guys at home, as an exercise, build the same bridge but have it extend twice as far by putting 2 pistons together and get them to coordinate in the same way. And we'll have a look at how to get that working at the beginning of the next episode. Bye.